Good morning, good afternoon, or good evening there, 8th graders. This is Mr. Warrington, and this is our first Edpuzzle lesson of the year. It's covering the topic of operational versus historical science. One thing to remember is that it would be very good for you to take notes as you go along. You should have received a notes packet in class. If you didn't, or if you misplaced it, or you left it at school, then you can go ahead and download a copy of those from Google Classroom, and then you'll be ready to use those. So I'm going to give you a moment or two here, I should say, in order for you to get set up and ready to go. And also don't forget, every once in a while those lovely questions will come up that you'll need to answer. So kind of look ahead for the little dot there to indicate that those are coming up. And remember, you can review a section a couple of times if you need to in order to get everything written down, or if you need to go back and understand it a little bit. But once you get to one of those dots, once you get to one of those questions, you can't go back. Okay? So feel free to go at your own pace, pause as often as you need to, replay as often as you need to, and then be ready for those questions. And don't forget to write your notes down as you go along. Those are the notes that you are going to use in order to study for the test over this chapter. All right, so let's go ahead, and after I give you a second or two here, we'll get started. All right, operational versus historical science. And this is one of those things that I think for many of us, when we understand this idea of these two different types of sciences, it will really help you to kind of deal with some of the issues that surround evolution or interpretations of Earth history that may be different than what the Bible talks about. So, you may have wondered why some kinds of scientific facts are generally agreed on by all or most scientists, such as the law of gravitation. All scientists are going to agree with this. In fact, Sir Isaac Newton, the man who discovered this mathematical relationship between mass and gravity and the radius of two objects, was a devout Christian. And no scientist, no serious scientist around the world is going to dispute this. There are many, many other things in science, such as the Krebs cycle in biology, photosynthesis, just many, many things in science. All scientists are going to agree on until something new may be discovered, maybe a refinement of the numbers involved in Newton's theory. But we know that there are those types of facts that do raise problems. For example, while they may not agree about other kinds of facts, such as how long it took for the Grand Canyon to form. So looking at the law of gravitation, which pretty much all scientists accept, and then disputes about how long it took the Grand Canyon to form. Some say it has taken millions of years for it to form, forming at a few centimeters per year, while there are some scientists who say that it formed basically within maybe just a few years, if not just a week or two. So here we go. Millions of years, one group of scientists might say. A few weeks, another scientist might say. So why is there a difference here where there wasn't a difference when it came to the law of gravitation? Well, I'm really, really glad you asked, because that is the crux of this lesson. That's the central idea of helping you to understand that there are really two different types of sciences. And some kinds of scientific research bias or presuppositions don't have much of an effect on the conclusion. But in other kinds of scientific research, different presuppositions can lead to very different conclusions. And we talked about that as we began the unit on worldviews last week. And here we're going to see how that kind of plays out in some types of science. So some scientists answer this dilemma by suggesting that there are two basic kinds of science: operational science and historical science. Now, that word "some scientists" up there is kind of crucial. You may remember a few years ago, Bill Nye debated Ken Ham, and Ken Ham used these two different ideas, operational science and historical science. Ken Ham responded to that by saying, you're basically the only person in the world that uses this distinction. Well, there's some truth in that, but at the same time, if you just take a few minutes to look at the two different types of science, it becomes obvious very quickly that there are two totally different types of approach to studying two different types of things. For example, operational science is also what we call experimental science. And it's the science you generally think about when you think about doing a lab in a science class, for example. Operational science sets out to describe how something works. For example, when we look at a cell phone, we can talk about the laws of physics that determine how the electricity inside the phone works. And that is a very, very consistent type of thing. If it wasn't consistent, then we couldn't be sure if a cell phone would ever work or not. Or when we look at the plastics or the other substances that are used inside the phone, we can describe the chemical reactions or the chemical formulas for those substances, and we can also describe the processes that were used in order to make those different materials, like plastics or whatever. Operational science is observable, repeatable, and testable in the present. Or another way of saying that is that it is experimental. Now, it's real important that you look at these three terms: observable, repeatable, and testable. These are the three characteristics of a problem that can be studied using operational science. First of all, it has to be observable. We have to be able to set up an experiment, for example, in which we can observe what's taking place using our different senses. It also has to be repeatable, so that if we do the experiment and we get a certain result out of the experiment, then we could turn around and do the same experiment again and get similar results, or someone else could do the same experiment and get similar results. That's what we mean when we say that it's repeatable. And then testable, that means that we can actually develop some kind of an experiment or a survey, and survey has a broad set of meanings. It could be a survey that people fill out about different things. It could be a wildlife survey that a scientist, a wildlife biologist, for example, would go out and they would count the number of deer in a certain area and then track that over time. But that's what we mean when we say that it's testable. And it's all of these things in the present, right now. We can do it now. We may have done it last week. We could do it a few weeks from now. But that it could be done in the present time. So again, this is what we mean by repeatable experiments. Now you may wonder why I said repeatable up here and experimental here and then said repeatable experiments. The reason for that is it's a hook, a mental hook that you can use in order to help you to remember what operational science has to do with repeatable experiments. And when we talk about historical science, I think you'll understand why I use this phrase here. Some examples of this kind of science: physics is almost totally operational science and is the foundation to all science, by the way. Chemistry is pretty much all, if not entirely, experimental science. Most biology is experimental, and even meteorology, the study of the weather, is experimental. And there are many others, but these are just some examples of this kind of science. So, I'm going to give you a moment here. There's a question coming up, and then after you answer that question, then we'll proceed on. Okay, let's take a look at historical science. And historical science, you can pretty much tell by the name that it sets out to explain how and what happened sometime in the past. Not in the present, like experimental science, but in the past, which makes it historical science. By the way, there is a bit of a difference between historical science and history. Historians, though, may use historical science to help them explain what happened in the past, and many times they actually use experimental science to help them what explained in the past. Now, if that sounds confusing, that's okay. I'm going to clear that up for you here in just a couple of minutes. Okay, historical science also makes observations in the present to develop inferences about the past. Now, an inference is a logical conclusion based on observations or experimental data even. Okay? So the historical scientist obviously cannot go to the past to see what happened, because if he did, when he got there, it would be in his present. Now, I know that sounds kind of confusing, but I think we can all understand that the only way to study the past is to look at things in the present that may have come from the past, such as this fossil over here. The fossil exists in the present, but it was formed in the past. We can make observations about what the fossil looks like today. We can take a look at the rock layers that it's in today, and all of that with the idea of trying to figure out what happened in the past, because we simply cannot go there. We can think of this as being reconstructions. Okay, and again, this is a mental hook for you to kind of help you to understand historical science versus operational science. And for operational science, we said repeatable experiments. And for historical science, we're saying reconstructions. Both of those start with the letter R, and so hopefully that'll help you to remember the two. Some different examples of this kind of science are paleontology, evolutionary biology, archaeology, and forensic science. So let's take a moment and look at those so you can understand what those are. Paleontology would be basically what this guy's doing right here. He is looking at fossils that were formed in the past and tries to figure out things about those organisms, what they looked like, what maybe they ate, the environment that they may have lived in, etc. Evolutionary biology is a science that tries to describe the path of evolution from the earliest unicellular organisms all the way up to human beings today over the course of millions and maybe even almost a billion years. That's what they attempt to do. And again, they're looking at things they can see in the present to try and figure out what happened in the past. Archaeology is the study of man's activities in the past. And this is kind of where history and science meet each other. Archaeologists will use all kinds of different things in order to kind of figure out what happened in the past. They'll look at artifacts from the past, for example, but they'll also use some very, very high-tech science to kind of figure out what has taken place in the past. And then, of course, forensic science we're all pretty much familiar with, where detectives will go into a crime scene and crime scene investigators will go in and they will look at evidence in the present to figure out what happened in the past. Now, in this case, the past may not have been too long ago. It may have been yesterday, but pretending for a moment here like nothing was caught on camera and that there are no living witnesses other than the person who committed the crime, then we have to try and piece together what took place in the past, even though it may have only been a day ago. Now, here's some important insights. Historical science takes what we can find out through operational science and tries to apply that to what we see in the present to explain the past. An example here is testing DNA to find out who was at the scene of a crime. So we're trying to figure out what happened maybe yesterday. We find some DNA at the crime scene, and then we use experimental science on that DNA to figure out who the DNA may belong to, and then that may help us to help us figure out who committed the crime. It definitely tells who was at the scene of the crime, perhaps, but who committed the crime is going to be based on a lot of different things, and there may be some presuppositions that come into play there to figure that out, such as this certain person whose DNA this is had a motive to commit the crime. They had the opportunity to do it, and they had the means of doing it. And so if we see someone like that, we might say, I think that person did it. And if their DNA is there, then that kind of helps us to narrow down on them a little bit. But then you have to look at a lot of other things, such as fingerprints and other pieces of evidence that could be taken from the crime scene. Ballistics, for example, where they examine a bullet and look for marks on it to figure out if it was fired by a certain gun. All of that is experimental science that is used to help draw conclusions for historical science. And I hope all that makes sense. And by the way, we'll talk about this in class tomorrow and see if all this makes sense to you. So, historical science relies heavily on presuppositions to arrive at an explanation of what happened in the past. If the assumptions are wrong, then so are the conclusions. Archaeologists, as I mentioned a little while ago, use all kinds of technology, experimental science things to take a look at what's happened in the past. For example, over this weekend I was watching some guys who were in Germany looking at a battle that happened over there, and they used a drone that they sent up with scanning radar and LiDAR, and they basically mapped out this whole area of what it looks like underneath all the trees and brush that have grown up in the last 80 years since that battle during World War II. And then they made a digital map of that whole battleground and through that they were able to find some things that were hidden underneath the brush and help them to understand different things that led to the results in the battle, the way the battle came out, which are things that are interesting to historians. But again, they're using experimental science to help them understand the past. But presuppositions can lead to different conclusions, and that is where some of the problems with historical science really come in. So another way of looking at this is with some final thoughts. First of all, only the present can be observed. We cannot observe the past directly. We can observe it indirectly through artifacts, through fossils, rock layers, those types of things, but we can't actually see what happened in the past. We can only come up with some ideas about what happened in the past, because the past obviously cannot be observed, and so can only be studied by observing in the present. And I thought this was just a nice way of kind of summarizing this whole lesson. Okay, tomorrow, or on, I should say, the day after this is due, this lesson, we'll watch a video that kind of summarizes things a bit, and then we will talk about it some more. But there's a question or two here for you that you need to answer. Okay, that wraps up this lesson. All is secure in Sector 7, and we will see you later. Take care. Bye-bye.